The Internet of Things is growing fast, but new connections bring new challenges: security, scalability, control. How do you get the best from IoT in the cloud without exposing your data and devices to the worst? Soracom is purpose-built for IoT, with affordable global connectivity and secure cloud integration to let you control, scale, connect, and protect your IoT network. From startup to enterprise, across industries and around the world, you create, we connect.
Hello everyone, welcome to another edition of one of our Soracom live streams. Today it's going to be a little different. We're not going to have any guests today, so it's just me, so please keep me company in the comments. If you have any questions or if you think I should make something crazier, please always open to ideas. Today we're going to be hacking with this guy. So this is the NVIDIA Jetson Nano. So it's a single board computer optimized for AI and ML projects. And I've got it on this WaveShare. Oh, 1 second. My echo just went off. So this is, it's on the WaveShare JetBot kit. So adds a little camera to it and some wheels. So I'm going to connect this to the Soracom network and up to the cloud using this. This is the Soracom Onyx LTE USB dongle. So let me just switch my camera here and so I can show you that better. Actually, we're going to switch to this. There we go. So yeah, again, so single board computer on a nice robot chassis. So it's got two motors. You've probably seen them before. They're those yellow geared motors that you can get from various robot kits. The Onyx LTE USB dongle, it just connects over USB, and so I've already activated our Soracom SIM card. See if I can open that. So it's already in there. So basically, this thing just gives you instant connectivity to the cloud. And so let me just share my screen here. And go back to my camera here. All right, so yeah, so I'm using the Jetson Nano developer kit. So I have the 2 GB model, but the specs are for the GPU, it's got a 128 core Maxwell processor, and it's got a quad core ARM A57. So it's pretty dang fast. You can do 4K video, it's got HDMI, USB, and of course, it's got a nice I/O header, kind of like a Raspberry Pi would have. I'm assuming that was intentional. And the dongle here, let's go back to Soracom. So Soracom, so I'm a developer evangelist at Soracom. We provide connectivity for IoT for cellular, Sigfox, LoRa. And we also have a cloud platform that lets you create cloud integrations pretty easily. So if you wanted to connect to an MQTT server, or you wanted to post out to a serverless function like AWS Lambda or Azure GCP, you could do all of that from our console. And so it's all built in from the get-go. So you're building cloud native with your edge devices. So to get started, I've already flashed an SD card with the base image for the Jetson Nano. So it's a flavor of Ubuntu. So we're gonna plug that in first. I'm gonna go back to my camera. There we are. Just gonna switch back to. So I'm going to see how far we can get with this. I'm thinking just as far as we're going to get this connected to the Soracom network, and then we're going to install some of the JetBot code, which will give it, I removed the other SD card, which will give it, it'll load up a Jupyter Notebook instance, so we'll be able to run some Python scripts, and we can do a test of sending messages out to the cloud, seeing that in the Soracom dashboard. And then we'll see if we can maybe get it to work with this robot drive system. I'm just going to plug this in. It's pretty great. It has like 3 batteries in it already, so it runs pretty well just on the charge it has now. But just in case, plug that in. Then I've got got a little monitor and keyboard, so that way we can get it all set up, and then we'll be able to SSH into it once it's all set up and connected to the network. Plug that in. HDMI for this. So just like a Raspberry Pi, there's a couple of different ways you can set it up. There's headless options if you pre-flashed your image with Wi-Fi credentials, or you can just do the old-fashioned way, which is get a keyboard and monitor. So this is a nice fold-out keyboard I've got. That's on, and then it's an on switch. Let's see. So that's just going to boot up now. All right. Let's just double check we have Wi-Fi connectivity. So we are connected to my home network. That's great. So we'll just do that so we can SSH and talk to it. So, all right. And I'm just going to double check. So one of the nice things is once you do have this connected, it automatically sets up its host name. Sometimes, depending on your network, it might not work, but you're usually able to SSH without knowing the IP address if you just know the name of the device. So let's see if I remember this from memory. Yeah. So we'll do SSH, and I believe I named it Sorabot, and it might be Sorabot desktop local. All right, cool. So this is just tunneling into it. This way I don't have to use the keyboard and monitor. I can just remotely configure it. So just say yes, add me to the fingerprint. I set a username and password earlier. Cool, so now we're in. Let's see if we can make that text a little bit bigger. There we go. All right, so now we're we're tunneled into the NVIDIA JetBot. And so what we want to do next is we want to install the Soracom Onyx dongle. So when you go to developers.soracom.io, you can go into the guides and find there's instructions to connect the Onyx dongle. It'll walk through setting up the SIM card, configuring that all on the console, and placing it into the modem, which I've already done. And then we're going to use the Linux installation. So for this one, instead of using the automated installation, you want to use the manual installation. And the reason for that is if you use the automated installation, it's going to, by default, route all network traffic through the modem. So if you have if you wanted to like fall over to Wi-Fi, it's not going to do that. It's going to default to cellular, which could be bad if you want to, pull down a lot of data if you're doing like updates or things like that, or if you want to SSH to it when you have it on your local network for reconfiguring and preparing it to be deployed. So the manual installation lets you run a command that specifies that only route traffic to the Soracom network through the USB modem. So the first command we're going to run is basically just installing the network manager. So this is a nice open source tool for working with USB modems. Also looks like it's already pre-installed on this flavor of Ubuntu, but this way we have it updated if need be. All right, and the next step is to plug in. Well, actually, we can take off. I'll take the keyboard out too while we're at it. So where did I put that modem? All right, it's got some modem, and it's best to use a USB extender if you can get a small one, because otherwise it just sticks out to the side, and that's probably not great for a robot. Then I'm just gonna tuck that in here. And we'll keep an eye on that. When it does connect, we'll see that light turn blue. All right, so the next step is LSUSB. So this is just a standard Linux command. It just says list USB devices. So I already know that this device ID corresponds to the Onyx modem. So that means it does see it. Let's make sure that the network manager also sees the modem. Cool, it sees it, so it's a Quectel module. Next step is to add the APN settings. So basically when you're connecting a cellular modem of any kind, you want to set the access point name. So in this case, Soracom.io, and then also the username and password, which is by default Sora on all Soracom devices. So this command just adds that in. All right, cool. So now we can manually start up this network connection by calling the network manager CLI and saying connection up Soracom, or we can also tear it down. But so that we don't lose SSH connection, I'm going to do this real quick, which is add those routes that I talked about. So this routes all traffic to Soracom services through the cell modem. Cool. So now if I turn that off, we should see it enable the connection. All right, it's taking a second. Maybe if I move this closer to the window slightly. Hope we still have connection here. All right, well, that's standing up the connection. I did want to mention that, so last week we did a, live stream on creating an IoT alarm, and we do have the GitHub repo up now, so if anybody saw that and was interested in building that with using the Soracom IoT starter kit, all the instructions for deploying the serverless app that accompanies it are all up on the GitHub repository for it, as well as how to load up the firmware. And if you just want to do anything basic with the IoT starter kit, I did publish a Hackster guide that walks through the basics of setting up your SIM card, setting up all the Soracom services, and flashing your Arduino device, whether you have the MKR 1400 or the 1500, and just publish arbitrary sensor data as a JSON message to the Soracom Harvest API, and then create a custom dashboard. So that is out there right now. All right, let's see. So we had a timeout with that command. So let's see why it did that. You know, what's possible is that it was already up. So just to be safe, I'm going to tear it down. And then we're going to bring it back up. All right, connection successful. Okay, oh, actually, we can see the light is doing a couple of things. So the best way to now test if this works is to ping out to one of the Soracom services. So you can actually do ping, so standard Linux command, ping a network, just it sends a bounce back to say, hey, can I reach this address? And we'll do pong.soracom.io. That's possible. We're not getting a solid connection yet. Let's double check we didn't miss any commands. So walking through again, we just installed the network manager. We checked that network manager can see the modem on the USB port. We set the APN settings, and then we set these IPv4 routes to the Soracom network. Okay, I think we're still having some issues here. All right, let's try that again. While we wait for this to connect, if anybody has any questions, please, again, drop them in the comments. I can see them all show up here on StreamYard. This online. Let's try this instead. All right. Interesting. Just to be safe, I'm going to do a quick reboot and see what happens. So we'll give that a second to reboot. I promise you it worked last night. All right. Well, while that reboots, the next step of things we're going to do is we're going to install the JetBot software. So again, this JetBot kit that I got is from Waveshare, and there's a bunch of different versions of it, but it's pretty much just kind of a guideline for how to build a robot around the NVIDIA Jetson Nano. So you can use either a pre-built SD card image or use a Docker container and add it to an existing one. Since I've already set up Ubuntu on this, we're going to go with this route. So we can start pretty much here because we've already set it up. We've already connected to Wi-Fi and we're using SSH to connect into it. So let's see if it's loaded back up. All right. Log back in. And let's try this. pingpong.soracom.io. There we go. Okay. So see that traffic is routing through the cell modem right now. So if we were to say, let's go to the Soracom console. Log in here. So we can see that the Sorabot is currently active. It's online. It actually even shows me where it is in the world. Please don't come to my house. And now we can go here. And we're going to go into groups. And so group is something you can configure a SIM device on. In this case, we've already configured the JetBot with the JetBot group. I'm just going to check the unified endpoint here. And I'm going to go to harvest data and enable this. So the unified endpoint is a single endpoint that you can post to that you can then configure to go to all the different Soracom services. So we just enabled harvest data, which is for data collection. So anything that gets posted to this as a JSON message gets packed and stored in Soracom Harvest, where you can then query it later by a date range, or you can create a live dashboard with Soracom Lagoon, or I could enable Soracom Func and have it talk to different serverless functions. So yeah, so all we would need to do is, I believe, post to this endpoint. So we'll grab that, and let's see, I'm going to quickly double check how you send a curl post. Let's see. All right, so if we do curl post and then data, then we're going to construct a little JSON object with something arbitrary like hello as our key, and our value is world. Post data, and then we just drop in our URL. Oh no, do we not have curl on here? All right, so we're going to quickly install curl. Let's see, so it's curl. Okay. I think if we just do sudo apt-get install curl, we should be able to get it. Okay. So again, curl is basically just a command line utility to make web requests. And in this case, we need to make a post request. So we're posting data up to the Soracom network. So let's try that again. Could not resolve host post. Oh, did I do that backwards? Okay, let's try this again. I'm going to copy this. Then grab the unified endpoint once more. Let's grab it again. All right. Let's double check. We configured those routes, correct? Maybe we should just go directly to harvest and see what happens. All right. Let's go into docs. We'll go to the Soracom Harvest Developer Guide and just double check how we talk to this API. So let's go to collecting data. Oh, looks like we have examples here already. Perfect. Let's see. So we do know it is connected and we have our network routed. So let's see if anything is coming through. And we'll set that, go a day back, and we'll select Sorabot. So to look at data, you just go to the data storage visualization, Soracom harvest data, select your resource type as a SIM, and then select that from that list. And then you can set a date range and search. So we'll fix this web request in a second, but if you'll notice, I'm not adding any credentials when I'm making this request. And part of that is because the SIM card itself is the authenticator. Because it's connected to the Soracom network and access to Soracom API is funneled through that, it already knows when it hits the Soracom network that, oh, you're this device. And I can make that more secure by setting an IMEI lock, which says only allow messages to be authenticated if they're coming from the SIM card that we know is associated with this account, and that SIM card is connecting with a very specific device. All right, looks like we're having issues with that. So we'll come back to that. We're going to install the JetBot code, and then once that Jupyter Notebook's loaded up, we'll run a little Python script to make a web request. So we'll go back to here. So we're just going to grab this. We're going to clone that JetBot repo. So I like to make a projects directory whenever I'm doing stuff like this. Let's change into that directory. And we're going to git clone the JetBot repository from GitHub. And the next step will be to navigate into the repository and run the configure script, which should set up all our parameters. All right, so it's configured a service for us. we've already enabled swap memory. When I set up the Nano, it asked me whether or not I wanted to enable swap memory. That was recommended, so I've done that already. Hi, 47 byte. See a comment there. Then we enabled the Docker containers. So Docker is basically a way to contain small VMs with code already in it. We'll cd change directory into the Docker folder in here, and we're enabling it. I feel like I need music in the background. So now it's pulling down that Docker image, it looks like. So while it does that, let's take a look at what else is going to happen here. So like I said, once this is installed and running, we'll be able to go to the IP address of the Jetson Nano from a browser, and it'll load up basically an instance of Jupyter Lab. And Jupyter notebooks are like interactive notebooks of code where you can have these cell blocks where you have executable Python scripts, and you can have like instructions and notes in there. So it's like a combination of a README and runnable code blocks. It's used primarily in data science and AI and ML. So I could have like step-by-step, like first thing I want to do is collect data, train a model, et cetera, et cetera. Or in the case of the JetBot, they have these notebooks where you configure things like, oh, this configures the controller with the separate Python script. This starts up the camera. This starts up a live feed within the Jupyter notebook that's pulling the image from the camera. And then here's the drive code, etc. And then you can also run a separate notebook to load up like an AI model that uses the camera to trigger messages when an image is recognized. We're going to create a small script that makes a web request through a Python request library. Just to give you an example of like how you can use Jupyter Notebook to also interface with the Soracom network. And then later on, probably not on this stream, we'll get into using Jupyter Notebooks to classify images, and then on image classification, send a message up through the Soracom network over the Onyx dongle into Soracom Harvest, and then kick off a series of events like, oh, I detected a cat, and I'm going to go chase after that, right, because it's a robot. And then maybe it texts you like, hey, there's a cat nearby, right? So, all right, download complete. So now we're extracting the Docker image. That's going to take another minute here. Yeah, like I said, there's all these examples that they've already have for the JetBot. Oh boy, is this taking a while. That's quite large, I see. Some other interesting projects out there as well for the Jetson Nano. So there's this repository, dustydashnv/Jetson inference. And they've got like a whole suite of like pre-trained model, code examples, hello worlds, all these Docker containers. So this is something I'll probably dive into another time as well, just because I know this one takes a while just to download all of the pre-trained models for detecting just tons of different images. So if you don't want to actually go through the process of training it for different things and you're just looking for general classification, this is probably the path to go, and you probably get a pretty good understanding of the basics of AI and ML using things like PyTorch and TensorNet and TensorFlow. Okay. While that keeps going, we're going to take a look back again at Again, I fly by wire with these streams. This is just hacking with me. So if anybody, again, has any questions or is interested in what else you can do with the Soracom network or with the Jetson Nano, please drop a comment. It's like washing paint dry. It's the final countdown. Actually, I wonder if we can do something in parallel here. So let's try this actually. Right, since we're tunneling in, we can actually create 2 sessions to the same device. Might take up some of its speed, but that's all right. Looks like it may just be a signal issue. I'm going to try tearing down the connection and then connecting it with a better USB port. So I've got this somewhere around here. Just so it doesn't knock into the other things. And then we will bring up that connection again. It's not detecting it. It's on there. Let's try this again. Okay. Now it should connect. I'm hoping it will just connect, and it was just an issue with this small extender cable I found lying around. Let's check on the Docker container, still downloading. Okay. Oh, cool. So it was just a USB port. Oh, SS asks, says, I like your headphone. Yeah, so these are just Beats with Soracom stickers on them. If anybody ever wants stickers, please reach out to us. Always happy to send stickers out. Cool, so let's try that curl command again. Now that that's connecting. Where did we have that? Up here. So. Okay, cool. So it looks like the Docker container is running. And I know this because when the JetBot code is running on the bottom of the JetBot shield or module, it has a small OLED that'll actually tell you its IP address when it's connected to Wi-Fi, which is useful if like the host name is not working on your network. You can just like type that in, connect to it, and you're good to go. just do this in Python with the Jupyter Notebook. Okay, so the next step in setting up the JetBot, let's go back here. So we enable the container, so we should be able to just go to the IP address. So Soracom, or Sorabot desktop.local, and then it's on port 8888, I think. Let's see if that works. Cool. And then the password, I believe, is the default password. Password is just JetBot. Cool. So this is actually all running off of the Jetson Nano. So now we can run like Python notebooks. It's actually got a bunch of examples built in already, but we're going to use just a Python 3 node. So we want to import requests. We'll see if it can do that. It might say it's not installed, but it might have actually be included. Sweet. So let's look up an example of how to do a request. Python 3 requests post. So this is just an example post I'm grabbing from W3 Schools. So we're going to swap out the default URL it's got there. Just send it that arbitrary data. That, I think, should be all we really need to send it. See what happens if we run that. Test the script again. Again, so like all this code that I'm writing in here now is actually just running remotely onto the Jetson Nano. So notice it just did that to make sure something was happening, so it must be failing somewhere. It's possible. So what I could do here is like put instructions, say like first do this, first do that, and then somebody can walk through it while learning it. Restart the kernel on this. So we're getting errors somewhere. Okay, so it is locking. All right. I'm gonna try using a more default library in case it's just having issues pulling down requests. All right. So this is a little script I had the other day for sending messages up to Slack, so we'll just reuse this. So this uses URL lib3. Unexpected indent. Where do we see that? Python can be very particular about its indents. Go ahead and restart that. Should be a way to debug this further. All right, well, we actually didn't have that print anything out, and we didn't get an error, so let's see if we do. So March 10th, just to be safe, I'm gonna do one rig over. Try that again. See, what we should be doing is printing out the request at the end. See if we get any errors. All right then. Maybe we change what server we're calling. All right, well, so I'm going to debug this a little bit later. Don't want to take up too much time, but we've gotten to a pretty good spot, right? So we've got the modem connected, running into a couple of things, possibly with signal issue where messages aren't getting out. That's more likely to do with that I live in a Faraday cage, essentially, than it actually being an issue with the modem. We got the JetBot code installed on the Jetson Nano, so now we can run Jupyter notebooks and run different scripts on the device remotely. And we have a small Python script that lets us send a request out to the Soracom API. Assuming we have connection, this part of the script can then send a message out, and then it can be collecting Soracom harvest data. If we go back to the lab, we can see if we can pull up one of the example tabs, and I can show you quickly how to run the robot commands. So let's see. So if we go into projects, I think it's in JetBot. There should be notebooks in here. Teleoperation. There's a couple different scripts in here. One is to do the controller. It actually comes with the game controller, which is pretty awesome. And so we could do something like this, create a camera widget. Oh, it's not liking this. I haven't said that. There we go. We'll just do this real quick. Then we can input. So again, this is how Jupyter notebooks work. You can just click through to add things. We are having an issue where something's not loading up though. But yeah, so if this, I think I have to connect something else on here to make it load that up, but you get the idea. You can write in your instructions, write a bunch of scripts. So if you were to combine this with the sending of messages up to Soracom, you can combine that with the object following, or perhaps like some of these other collision avoidance scripts, and you take any significant events that occur and publish that. So with that, I'm gonna cut the stream today, so we're getting at close to the end of the hour. If there's ever any questions, you can reach to me at @VirgilVox on Twitter. You can check out our YouTube channel. We have a Twitch, twitch.tv/Soracom IoT. My DMs are always open, whether it's for a project that just in the general maker sense of things, or if it's a Soracom related project, I'm always happy to help and support the community. So with that, I will see y'all later. Hack the planet.